Hi, it's Joe here, ZL1PNY, and on the bench today we've got a Tono 250 watt linear amplifier. Quite an old thing, I think it dates back to the 1980s, and it's been sent in because it is tripping. Even on a dummy load it trips, and once it's tripped you've got to power it off and power it on to reset it. Initially, we've looked at the circuit, and the alarms which deal with over voltage and the bad SWR, etc., are all achieved by use of a quad comparator down here, and using a cable from the 12 volt supply and a 10k resistor. We've gone around the comparator and checked that it is working as a comparator, and it is, so that's not the problem. The references for forward and backwards tripping are the potentiometers here. Now there's nothing on the web at all. There's a circuit diagram of this unit on the web, but there's nothing in terms of how you set it up and what voltage, etc. So we just come around to doing the power tests, where we're driving it. We're using this old icon, which is 2 meters SSB. I didn't mention it, but this amplifier is VHF only, and at the back we've got the 1 kilowatt dummy load with power meter. Now, one thing that I've noticed, and I have had trouble with these before, and I think I did mention it in one of my videos, someone's replaced this connector, and this connector is a Chinese one. And what we've noticed with all these Chinese PL259s is they don't meet the standard, or the international standard. So when we put a connector in and we rotate it, and that is now tight, you can see that the body of the connector isn't actually grounding. So that would have been working into an antenna without a ground, and I reckon that's a very likely cause of it tripping. Now, on normal UHF connectors, PL259s, they have 2 V's which should locate in these little slots. Try and do a close-up. It has these little grooves all around the outside. In fact, I think there's about 6 altogether, and within the connector, see if we can see that down at the bottom there, you can see there are raised pieces which are supposed to locate into there, and that carries the ground. You can't rely on the threads, especially with a plated connector, to carry the ground. So what I'm going to do is find a different type. This is an adapter. I'll find a proper UHF connector, and we'll see whether that grounding problem is actually the same on a different type of connector. So I'll be back with you quite soon. So back with you now, and what we found, a test lead with a proper UHF connector on it. However, this connector is also Chinese made, and when we screw that onto there, and remember, you shouldn't need to use tools, you know, finger tight should be good enough, and that's quite tight. You can see that that body is still free to turn. So the earthing connection to the antenna is actually not made properly. You can see that that will move up and down, and that will give you an intermittent connection on the earth to whatever antenna is being used. So I'm going to hook it up and power the amplifier up and see if it does trip, and then we're going to have to find a proper non-Chinese socket and plug and see if that cures the problem. But we have had this on our field day, where we pre-made cables, went out on the Jock White field day. This was in 2021, and we were really quite late getting into the field day that year because the leads we'd made up were all like this and would not tighten up. Even with pliers, we couldn't get a tight connection, and I can't undo that now. Hang on. And as I said in the previous segment, at the bottom of these connectors there are little raised pieces which locate in these slots, and that's how you get an earth connection through to the antenna, which isn't loose, doesn't flop about and lose its connection. So let me hook that up, we'll give it a drive and we'll see what happens. Okay, so we got that hooked up to drive, and that's on. Here is the trip light. So I've got it in FM mode, I'm feeding 10 watts FM in, and the amplifier is consuming 20 watts. And the meter here claims 200 watts, but we're not getting 200 watts out, don't know why. But the important thing is I'm going to key the radio up now and then just move that loose connector that I've just shown you, the 259, and it trips immediately. So I'm just going to do that. So here's the mic, and we're going to key it up, and we're taking 20 amps, and as soon as I touch the connector on the back, it trips. So I think that's pretty conclusive that you know, that socket isn't up to the job. It's mechanically, they don't fit, and as I say, all the ones I've bought from China are the same, they just don't mate properly. And what we're going to have to do is try and find an Amphenol panel mount female connector, and just advise the user that he needs to get, you know, proper manufactured connectors rather than these cheap Chinese things. So I've got a couple of other things to check on the amplifier, and I want to check why we're not showing 200 watts out on the Big Bird 1 kilowatt meter, and to do that I need to set up something else. But in essence, that's the problem of this particular amplifier. I'm also not enough power, my power supply is only 20 watts, so I'm going to have to get a battery and run it via a battery as well. So leave that with me and I'll be right with you as soon as. Right, so we've got the larger power pack on now, so there's ample current and the unit trips straight away. So we're continuing on. What I did is I bypassed that socket. I've actually wired this cable, which is going directly into the dummy load. And what I've noticed is on the drive radio, the VSWR is infinite, it's high. So there should be a through path from this connector through this relay into that one, so the rig can work barefoot, as you like. You can see the aerial. So putting the meter on the output there, you can see on there we've got 51.4 ohms, so that's the dummy load. And coming over to the drive side, we put the meter on there, and it's 18 mega ohms, it's open circuit. So there's obviously no connectivity between the input and the output when the unit is actually switched off, which there should be. So it's quite likely that this relay or the print underneath has gone. You can see here there's a corner being melted with a soldering iron when this work was done. So whether that's restricting the movement of the leaf of the relay, I don't know. We're just going to pop the lid off that, and then failing that, if it's still the same, it will be probably a burned out track. And we're going to have to take the board off and clean all the heat coolant off and all that sort of stuff, and it turns into a much bigger job. So yeah, I'll be back with you. We'll do that little bit of investigation off camera, and I'll come back and report what we find. Okay, so here's the root of the problem. This is one of the relays which switches the antenna routing. So on this side you've got normally closed and normally open, and normally closed and normally open, and as you can see that one is short circuit. So that is then routing the aerial to ground, thus changing the SWR and absorbing probably lots of drive as well. So I'm not sure if the PAs have survived. I'll just show you the board. We've got it upside down, so we're going to put two new relays in, put new heatsink compound on and put it all together. One of the meters has become a casualty. We tried to reset it and it didn't work, so we'll have to see what we can. So we're in the phase of putting it all back together now. We've changed the electrolytics around the control circuit because they'll be quite old. The screws on the PA, the problem we have, well, we've got 3 that just won't tighten up. So we're going to have to think about maybe putting a self-tapper in, drilling a bit deeper and putting self-tappers in. I can't drill the hole out for a larger screw and tap it because the flange on the transistors are not going to take that. We've also got put some RG316 on the output. That's good for 350 watts at 200 megs, so that should be okay. And we've got a proper PL259 panel mount socket, which should solve the problem of tightening the coaxial connectors. So I just need to ponder this problem with the PA, and then we can actually put it all back together. There's no point gluing the LEDs in. The LEDs all came away when we stripped it, and there's no point gluing them all back until we've sorted the heatsink problem and tested it under power. So we've just got it all nearly back together. Just to go over it, we've still got the switches hanging out on the little LEDs off the front panel. We put a new socket on, which is nice and tight, 316 coax. The answer to the screw problem was to put an M3 bottom tap in the hole, and we got maybe a couple of turns on that, that's all. And then we've used longer screws with a compression washer underneath. Apologies that they're slot type. I don't really like them, prefer Phillips, but I haven't got any. So we've got it in FM mode now from the radio. This is a very old set, it only produces about 10 watts, if that. And on test we've got, I've forgotten that my 1 kilowatt bird dummy load is HF only. That's why it doesn't show the right power on VHF. So we've put the through line into that as a dummy load, and the slug in the through line is a 200 watt, 100 to 350 megahertz. And if I chuck about 10 watts in there, we've now got 150-ish, 155-ish, like that. We've also changed all the capacitors because the hang time for SSB wasn't working. So if I put that in SSB mode now, 1, 2, 3, 4, 5, 5, 5, and you can hear the relay click out just about 100 milliseconds later. 1, 2, 1, 2, 3, 4, 5, 5, haul up, haul up. So yeah, I think we're more or less done. Just got to glue in the bits and pieces. I just need to check that those washers are correctly seated and that we have got some heat going to the heat sink, and we'll be putting it back into its box for a final test. So if anything crops up, I'll make another segment, otherwise this video is done. Thanks for watching. This is Joe ZL1PMY signing off.